Come, sit with me for a moment. Let us quiet our busy minds and cast our thoughts back. Back beyond our own memories, beyond the memories of our grandparents, and even beyond the oldest stories ever told. We are about to embark on a journey of immense proportions, a voyage that spans not just centuries or millennia, but billions of years. This is the story of us. It is a tale of survival, of change, and of extraordinary transformation. It is written not in books of ink and paper, but in the very rock beneath our feet, in the ancient bones of creatures long vanished, and in the intricate code that is carried within every single one of us. It is the greatest story of all. Our planet, this beautiful blue sphere, spinning in the vast, silent theatre of space, was not always so welcoming. For an unimaginable length of time, it was a world of fire and fury, a chaotic place of molten rock and violent storms. But even in this seemingly inhospitable environment, something truly remarkable was about to happen. Deep within the primordial oceans, under a sky very different from our own, the first whispers of life began. It was a beginning so humble, so microscopic, that it would have been entirely invisible to our eyes. Yet from this infinitesimally small start, a chain of events was set in motion that would ultimately lead, after countless eons, to you and to me. Think of time not as a straight line, but as a vast branching tree. Every twig, every leaf represents a different form of life, a different experiment in existence. Our story is not one of a direct, purposeful march towards humanity. Instead, it is a meandering path, filled with chance encounters, dead ends, and astonishing leaps of innovation. We are but one small branch on this immense and ancient tree of life. But by tracing our branch back towards its trunk, we can begin to understand the incredible series of events that gave rise to our own unique existence. It is a journey that connects us to every living thing, past and present. So, let us begin. Let us travel back to a time when the world was young and life was a new and fragile idea. We will witness the slow, patient dance of evolution, a process that works on a time scale almost beyond our comprehension. We will meet our distant ancestors, creatures both strange and surprisingly familiar. We will see how a series of small changes, accumulating over millions of generations, sculpted the beings who would one day learn to walk on two legs, to craft tools from stone, and to look up at the stars and wonder. This is our shared inheritance, the epic of our origins. Our journey starts in the water. Billions of years ago, the Earth's oceans were a chemical soup, a rich broth of minerals and compounds bathed in the energy of the young sun. It was here, in this warm, aquatic cradle, that the miracle of life began. The first living things were not animals or plants, as we know them. They were far, far simpler. Imagine a single microscopic cell, a tiny bubble containing the basic machinery of life. For an immense period of time, perhaps for 2 billion years or more, these simple organisms were the sole inhabitants of our planet. They floated, they divided, and they slowly began to change the world around them. These early life forms, simple bacteria and archaea, were profoundly important. Through their quiet, persistent activity, they began to alter the very chemistry of the Earth. Some of them learned a remarkable new trick: photosynthesis. They captured the energy of sunlight and, as a byproduct, released a gas called oxygen. At first, this oxygen was a poison to most other life forms, but over hundreds of millions of years it gradually accumulated, transforming the atmosphere and the oceans. This great oxidation event was one of the most significant changes in our planet's history, paving the way for new, more complex forms of life that could harness the power of this new gas. With an oxygen-rich world, a new possibility arose: complexity. Single cells began to cooperate, to band together. Perhaps at first it was an accident, a group of cells failing to separate after dividing. But this cooperation offered advantages. Some cells could specialize in movement, others in feeding, and others in reproduction. This division of labor was the birth of multicellular life. The first complex organisms appeared in the oceans, creatures like sponges and strange fern-like beings that are unlike anything alive today. They were soft-bodied and left only faint impressions in the ancient mud, ghosts of a world taking its first steps towards biological diversity. This was a time of quiet, slow-motion revolution. The world was still silent, save for the whisper of the wind and the crash of waves. There were no creatures on the land, no birds in the sky. All the drama of life was playing out beneath the surface of the water. Yet the stage was being set. The basic body plans that would eventually give rise to insects, to fish, to reptiles, and ultimately to us, were being sketched out in these ancient seas. From the humble beginnings of a single cell, life had diversified into a weird and wonderful collection of pioneering new forms, each one an experiment in survival. Among the myriad of new life forms emerging in the oceans, one particular innovation proved to be a game-changer. This was the development of an internal segmented rod of cartilage or bone, the backbone. The first vertebrates, the ancestors of all fish, amphibians, reptiles, birds, and mammals, had arrived. At first they were simple, jawless fish, filtering food from the water. But having a backbone provided a strong, flexible framework for muscles to attach to. This allowed for more powerful, controlled movement. It was a revolutionary piece of biological engineering that opened up a world of new possibilities for locomotion and predation. The oceans became a dynamic and often dangerous place. Jaws evolved armed with teeth, turning simple filter feeders into formidable hunters. An evolutionary arms race began. Predators developed more speed and power, while prey developed armor, camouflage, and new escape tactics. It was during this period, the Paleozoic era, that fish diversified into an astonishing array of forms. Some, like the giant Dunkleosteus, were armoured predators the size of a bus. Others were small and nimble, darting through the newly evolving coral reefs. The blueprint for the modern vertebrate body was being perfected in this aquatic arena. But the land beckoned. It was a vast empty continent, rich in resources and free from aquatic predators. The first pioneers to venture out of the water were likely plants and small invertebrates like insects and millipedes. For the vertebrates, the transition was more challenging. It required a whole new set of adaptations: limbs to support weight, lungs to breathe air, and skin that could resist drying out. One group of fish, the lobe-finned fishes, possessed a crucial pre-adaptation. Their fins were fleshy and supported by bones, a structure that was a precursor to the legs of terrestrial animals. One of these creatures, something like the famous Tiktaalik, was a transitional marvel. It had gills and scales like a fish, but it also had a flattened skull with eyes on top, a mobile neck, and robust fins that could prop up its body in shallow water. It could push itself along the muddy bottoms and perhaps even haul itself onto the bank for short periods. From these humble amphibious pioneers, a great dynasty of land-dwelling vertebrates would arise. They had taken a monumental step, carrying their backbones out of the water and into a new world, setting the stage for the age of amphibians, the rise of reptiles, and, eventually, the distant dawn of mammals. After the great age of reptiles and the dramatic extinction that wiped out the dinosaurs, the world was a changed place. New opportunities opened up for the small, shrew-like mammals that had lived in the shadows of the giant reptiles for millions of years. With their main predators gone, mammals began to diversify with explosive speed, filling the ecological niches that were now vacant. One group of these early mammals took to the trees. The vast, spreading forests of the Cenozoic era offered safety from ground-dwelling predators, as well as an abundance of food in the form of fruits, leaves, and insects. This was the environment that shaped the first primates. Life in the trees demands a very specific set of skills. It requires an excellent sense of balance and a three-dimensional understanding of space. To navigate this complex arboreal world, our primate ancestors evolved grasping hands and feet with opposable thumbs and big toes that could securely grip branches. Instead of claws, they developed sensitive fingertips protected by flat nails, allowing for a more delicate sense of touch. This was crucial for testing the stability of a branch or for manipulating food. These adaptations made them masters of their leafy kingdom, agile climbers leaping through the canopy. Perhaps the most significant change occurred in the way they perceived the world. Life in the trees places a premium on vision over smell. To judge the distance of a leap from one branch to another is a matter of life and death. This evolutionary pressure favoured a shift in the skull. The snout began to shorten, and the eyes migrated from the sides of the head to the front. This forward-facing position allowed the fields of vision from each eye to overlap, creating stereoscopic or three-dimensional vision. The world suddenly had depth, making navigation and the capture of prey far more precise. The brain devoted more and more processing power to this rich visual information. This combination of traits, grasping hands, sensitive fingers, and sharp three-dimensional vision, required a more powerful and complex brain to coordinate it all. The primate brain began to expand, particularly the regions associated with vision, touch, and fine motor control. These early primates were likely small, nocturnal creatures, perhaps resembling modern-day lemurs or tarsiers. They were not yet human, not by a very long stretch. But in their hands, their eyes, and their growing brains, the essential toolkit of our own lineage was being assembled piece by piece, high up in the branches of the ancient forest. Section 5. A monumental step. The arrival of bipedalism. For millions of years, our primate ancestors thrived in the lush green forests of Africa. But you know, the world is never static. The climate began to change, becoming cooler and drier. The vast, continuous rainforests started to shrink, replaced by a mosaic of woodlands and open grasslands, the savanna. This changing landscape presented our ancestors with a whole new set of challenges and opportunities. Food sources were now more spread out, and moving between patches of trees meant crossing open, exposed ground where predators might be lurking. It was in this environment that a truly revolutionary adaptation appeared. Walking on two legs. This shift to bipedalism wasn't a sudden event, but rather a gradual transition that took millions of years. Fossils of early hominins, like the famous Lucy or Australopithecus afarensis, show a curious mix of features. Her pelvis and leg bones are clearly adapted for upright walking, much like our own. Yet she retained long arms and curved fingers, suggesting she was still quite comfortable climbing trees, perhaps to find food or to seek safety at night. These early ancestors were creatures of two worlds, the forest and the savanna, and their skeletons tell the story of this crucial transition from a life in the trees to a life on the ground. Now, why walk on two legs? The advantages must have been significant. One of the most important benefits was the freeing of the hands. An animal that walks on its hind limbs can use its hands for other tasks. It can carry food back to a home base, allowing for sharing and provisioning of family members. It can carry infants, making it easier to move long distances with vulnerable young. And, crucially, it can carry tools or weapons. Standing upright also provided a better vantage point over the tall savanna grasses, making it easier to spot predators or to locate distant resources like a fruiting tree or a carcass. Walking upright, however, came with its own set of costs. It required a major re-engineering of the skeleton, from the base of the skull, where the spine connects, down through the S-shaped curve of the spine, the broad, bowl-shaped pelvis, and the angled-in thigh bones, all the way to the arched feet. This new posture placed enormous strain on the lower back and hips. It also made childbirth more difficult and dangerous, as the birth canal had to be narrowed to accommodate the demands of bipedal locomotion. Despite these drawbacks, the benefits of this new way of moving were so profound that it set our lineage on a completely new evolutionary trajectory. Section 6. The first toolmakers. Shaping a new world. The hands, freed from the burden of walking, were now available for a new and profound purpose, to make things. While other animals, like chimpanzees or crows, use simple tools, our ancestors took this ability to an entirely new level. Around 2.6 million years ago, we see the first clear evidence of stone tool manufacturing. These were not complex implements. They were simple flakes of rock knocked off a coarse stone with another. Known as the older one toolkit, these sharp-edged flakes may seem crude to us, but they were a revolutionary technology. For the first time, an animal was deliberately shaping one object to modify another. These simple tools were transformative. A sharp stone flake could do what teeth and fingernails could not. It could be used to slice through the thick hide of a large animal, giving our ancestors access to a rich new source of food, meat and marrow scavenged from the carcasses of animals killed by other predators. This high-energy diet provided the fuel needed to power a larger, more energy-hungry brain. The act of making the tools itself also spurred on cognitive development. It required foresight, planning and a sophisticated understanding of fracture mechanics, knowing just where and how hard to strike a stone to produce a useful flake. The first toolmaker was likely a species known as Homo habilis, which means handyman. The appearance of this species marks a significant step in our story. Their brains were larger than those of the earlier Australopithecines, and their hands were more capable of the fine manipulation needed for tool-making. This initiated a powerful feedback loop. Making tools allowed for a better diet. A better diet fueled a bigger brain, and a bigger brain could then conceive of and create even better tools. This interplay between culture, like tool-making, and biology, such as brain size, would become a defining feature of human evolution. For nearly 1 million years, this simple toolkit remained largely unchanged. But it represented a fundamental shift in our relationship with the world. We were no longer just adapting to our environment. We were beginning to shape it. We were creating a culture, a body of knowledge and skills that could be passed down from one generation to the next. The sound of stone striking stone, echoing across the ancient African savanna, was the sound of a new kind of consciousness dawning. It was the first act in a long play of technological innovation that continues to this day. Section 7. The Power of Fire. A flicker of revolution. Imagine, if you will, the world of our early ancestors. When the sun dipped below the horizon, the world was plunged into a profound darkness, filled with the eerie sounds of nocturnal predators. The night was a time of fear and vulnerability for them. Then, one fateful day, everything changed. Our ancestors learned to control fire. We do not know precisely how or when this remarkable event occurred. Perhaps it began with the opportunistic use of a natural fire, ignited by a lightning strike. An ancestor might have bravely carried a smouldering branch back to a cave. The moment one of our ancestors learned not just to use fire, but to create it at will, was arguably one of the most significant moments in human history. Fire provided a circle of light and warmth in the cold, dangerous night. It kept predators at bay, extended the usable hours of the day, and created a safe space for social interaction. Around the flickering flames of the campfire, our ancestors could gather. This became the first living room, a place for sharing food, mending tools, and strengthening social bonds. The darkness was no longer a wall of impenetrable fear, but a backdrop to a new kind of community. The psychological impact of this newfound security cannot be overstated. It gave us a mastery over the night, a domain that had previously belonged only to our predators. Beyond warmth and protection, fire revolutionized our diet. Cooking food is a form of external digestion. It breaks down tough fibers and complex carbohydrates, making food easier to chew and digest. It also kills bacteria and parasites, making food safer to eat. This meant that our bodies could extract far more energy from the same amount of food. This surplus of calories was a crucial factor in the continued expansion of the human brain, the most energy-intensive organ in our bodies. A diet of cooked meat and tubers provided the high-quality fuel necessary for our brains to grow larger and more complex. The control of fire also allowed our ancestors to expand into new environments. With a portable source of warmth, we were no longer confined to the warm climates of Africa. We could survive the colder winters of Europe and Asia. Fire allowed us to harden the tips of wooden spears, creating more effective hunting weapons. It could be used to clear landscapes or to drive animals towards a hunting party. This single technology, the control of a chemical reaction, fundamentally altered our place in the food chain and gave us the power to begin reshaping ecosystems on a large scale. The tiny flicker of that first controlled flame was the spark of civilization. Section 8. The birth of language. Weaving the social fabric. As our brains grew larger and our social lives became more complex, another more subtle revolution was taking place. This was the development of language. Unlike stone tools or the ashes of a campfire, language leaves no direct fossil. Its origins are therefore one of the great mysteries of human evolution. However, we can find clues in the anatomy of our ancestors and in the complex behaviours they engaged in. The ability to produce the wide range of sounds necessary for modern speech depends on the specific shape and position of our larynx or voice box. By studying the base of fossil skulls, we can infer when this modern vocal anatomy might have begun to emerge. Early communication was likely a mixture of gestures, body language, and simple vocalizations, much like what we see in our primate cousins today. But as the need for cooperation grew, so did the pressure for a more efficient and detailed method of communication. Imagine trying to coordinate a group hunt for a large animal, or teaching a youngster how to make a complex stone tool using only grunts and gestures. A system of shared symbols, words, would make such tasks infinitely easier. Language allowed for the precise transfer of complex information from one mind to another. Language did more than just allow for better cooperation in the present. It allowed us to talk about things that were not right in front of us. It allowed us to speak of the past. Yesterday we saw a herd of bison by the river, and to plan for the future. Tomorrow we will hunt them at dawn. This ability to mentally time travel, to learn from the past and to coordinate future actions was a cognitive superpower. It also allowed for the creation of a shared identity of myths, stories and social rules. It was the glue that could bind together not just a small family, but a large tribe. The development of language and the expansion of the brain were intimately linked. Language is not just a tool for communication, it is a tool for thought. It allows us to categorize the world, to form abstract concepts, and to structure our own thinking in complex ways. The internal monologue that runs in our own minds is a testament to this. The arrival of complex language was the final, crucial step in the making of the modern human mind. It transformed us from clever apes into beings who could build a shared culture, a collective memory, and a symbolic world of unprecedented richness. Section 9. The Great Migration. Out of Africa and across the globe. Armed with sophisticated tools, the control of fire and the power of language, our species Homo sapiens was ready for its greatest adventure. For millions of years, the story of human evolution had been largely confined to the African continent. But beginning around 100,000 years ago, and in a major wave around 60,000 years ago, modern humans began to leave Africa and spread across the entire planet. This was not a single, organized expedition, but a slow, multi-generational process of expansion, a trickling of people into new lands, perhaps following coastlines or herds of migratory animals. This journey was one of incredible courage and adaptability. As our ancestors moved into Asia, they encountered new climates, new landscapes, and new species of plants and animals. They learned to hunt mammoths on the frozen steppes of Siberia and to build rafts to cross stretches of water to islands in Southeast Asia. Around 50,000 years ago, they made a remarkable sea crossing to reach the continent of Australia, a land with a completely alien fauna. By about 45,000 years ago, they had pushed deep into Europe, where they encountered another human species, the Neanderthals, who had lived there for hundreds of thousands of years. The final great frontier was the Americas. During the last ice age, when sea levels were much lower, a land bridge connected Siberia and Alaska. Sometime after 20,000 years ago, small bands of hunters crossed this bridge, following herds of bison and mammoth into a new hemisphere. From there they spread south with astonishing speed. Within just a few thousand years, their descendants had reached the very tip of South America, having adapted to every conceivable environment along the way, from Arctic tundra to high-altitude mountains and dense tropical rainforests. It was the fastest and most extensive geographic expansion of any species in our planet's history. In the space of just a few tens of thousands of years, a mere blink of an eye in geological time, our species had gone from being a localized African hominin to a truly global presence. No other large animal had ever managed to colonize every continent on Earth. This great migration is a testament to the extraordinary flexibility of the human mind and the power of our culture. Our biology did not change significantly during this expansion. Instead, we used our intelligence and our ability to share knowledge to invent new technologies and new behaviors to solve the challenges of each new environment. We had become the planet's ultimate generalists. Section 10. Echoes of the Past. Reflections in the human mirror. And so our journey through deep time brings us back to the present day. We look around at our world of bustling cities, of digital technology, of art and science, and it can feel utterly removed from the ancient savanna or the Ice Age tundra. Yet we are not separate from that past. We carry it with us every single day. The way our hands are shaped, the way we walk on two legs, our innate ability to learn language, our love of a warm fire, and our deep-seated need for social connection. All these things are echoes of that immense journey. Our bodies and minds were sculpted by the challenges and opportunities of a world that no longer exists. Understanding this long story of our origins gives us a profound sense of perspective. It reminds us that we are a part of the natural world, not apart from it. We are connected by a shared thread of ancestry to every other living thing on this planet. The same evolutionary process that gave rise to the first simple cells in the ancient ocean also gave rise to us. This shared heritage should inspire in us a sense of humility and a feeling of kinship with all life. We are the improbable result of 4 billion years of trial and error, a species that has been gifted with a unique and powerful consciousness. The story of our past also holds important lessons for our future. It shows us that our greatest strengths have always been our adaptability, our creativity, and our ability to cooperate. We have faced existential challenges before: climate change, resource scarcity, new environments, and we have overcome them by working together and by inventing new ways of doing things. The challenges we face today on a global scale are immense, but our history tells us that we possess the ingenuity and the social capacity to solve them if we choose to use them wisely. When we look into the mirror, we see the face of an animal with a 4 billion year past. We are the custodians of an extraordinary legacy. We are the storytellers, the toolmakers, the explorers who walked out of Africa and settled the world. We are the inheritors of the minds that first learned to speak and to wonder at the stars. This incredible journey from a single cell to a sentient being capable of contemplating its own origins is the story of humanity. And knowing this story in all its depth and wonder is essential to understanding who we are and what we might yet become.